everybody. In this video, I will show you some more features of Numpy that can be useful in data generation. Alright, so in some cases when you want to generate data quickly, such as a bunch of ones and zeros, we can generate them using Numpy library functions. So first of all, I will import Numpy in my Google Colab notebook as NP. It will take some time to load first. So when I will use np.zeros function and then pass in the number of zeros I want. Right now I will pass in just a random value. Let's take 4, execute, and this will return a vector of 4 zeros. Now here you might notice something, that these zeros have a decimal point with them. And the reason behind that is that floating point numbers are useful in machine learning because they allow for more precise calculation and can represent a wider range of values than integers. This makes them particularly useful for tasks like gradient descent, which requires precise calculation to find the optimal solution. Don't worry if you haven't understood what I mean by that, but keep in mind that the thing that I'm going to be teaching right now will be very important later. So here, as you can see, that we have 1D vector of zeros. Now let's see how to create multiple vectors. So in order to make multiple vectors, basically a matrix, first I will call the function from the Numpy library np.zeros with brackets, and now I will create another bracket inside of it, and then I'll pass in the dimension that I want my zeros to be created in. Let's take 4 by 4. As you can see that we have 4 rows and 4 columns. And now let's begin to modify this. Let's say 4 rows and 8 columns. Now let's take a look at how to create ones. Basically it's the same as creating zeros, but anyway, let me show you an example of it. np.ones bracket. So I need 5 rows and 10 columns. Now I believe this all makes sense to you. Now let's talk about linscape function. It is basically used to create an evenly spaced sequence in a specified interval. Let's see how to implement it in practice. To start off, I'll say np.linspace. Keep in mind that the name of the function is linspace, not linespace. Now in the brackets, I'm supposed to pass in 3 arguments. First one is the starting point. Second one is the ending point. The third one is the number of elements you want that are evenly spaced out. Let's see an example of it. So my starting point will be 0 and the ending point will be 8, and then the number of elements that I want is 3. As you can see that I have 3 elements that are evenly spaced out. First one is 0, then 4, then 8. Let me modify it again. Starting point will be 0, ending point will be 10, and the number of elements that I want is 3. So as you can see, again I received 3 elements as I specified in the argument. Now if I will say instead of 3, I'll say 5. You can see that I got 5 elements that are evenly spaced out. Now finally we have I function. It is used to return a 2-dimensional array with ones on the diagonal and zeros. Let's see an example of it. np.I and 4. Now this will give me 4 by 4 matrix with 1 along the diagonal. Perfect. So now that's it for this video. In the next part of Numpy, I will be finishing the topic of generating data with Numpy, because in the next part of this video, we will be talking about generating random data using Numpy.